Hello, let's continue our Sudoku adventure with Leftovers by Strosahl. So we have normal 6x6 Sudoku rules. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have killer cages in the grid. Digits in a cage sum to the value in the top left. So these three would sum to 9. Maybe it's 1 here, 2 here, and a 6 here. 1, 2, 6, that's 9. One way to do that. All right, we also have same difference lines. We've been doing these all week. The way these work is whatever, all pairs of digits on the line have the same absolute difference. Absolute difference means just take the bigger one minus the smaller one. We're always going to be positive. That difference must match across the whole line. But we have to discover what the difference is per line. So for example, if we discover that this is 2 and 4, like this, then we know now the difference is 2. So the 4 could maybe go up to 6 and then back down to 4. And that would be a valid fill of the line. If instead we discover this is 2, 3, then maybe that means the difference is 1. So maybe we go back down to 2 and then down to 1. Or we could go up to 4 and then up to 5 again. All right. That's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right. These are actually givens. I think this is why the puzzle's called Leftovers. Why are they givens? Well, we know the entire box adds to 21. We also know that these 5 cells add to 19. So 5 out of the 6 cells add to 19. This is the one out. 21 minus 19 is 2. So over here, 21 minus 17 is 4. All right, now how are we getting from 2 to 4? Okay, so there's one thing, which is that we know that this difference isn't odd. Because if this difference was odd, odd always flips parity as we move along. So if this difference was odd, say it was a difference of 3, right? We go from 2 to 5. That's a difference of 3. Notice that we go from even to odd. And then a difference of 3 again is going to bring us back to even. And then a difference of 3 would be odd, right? So if this had an odd difference, then we would have to go even, odd, but we don't. This is also even. So we know we have an even difference. Now the issue is if that would mean our options are 2 or 4. A difference of 6 isn't possible because we don't have digits that big. So a difference of 4 would actually force us to go 2, 6, 2, and then back to 6, and that's no good. So we know we have a difference of 1. If we went down to 1, we wouldn't be able to get back up to 4. So we're going to go 2 to 3, and then this could be a 2. Wait, is it 2 to sorry, I said difference of 2, not difference of 1. Sorry, let's try that again. We go from 2 to 4. That's the only way to have a difference of 2. And then from the 4, we would go to 2 or 6, because it doesn't matter, because we could either add 2 or subtract 2 to get back down to 4. Okay. Sorry, that was a weird hiccup, but I got there. We do have some 4s here. 4s down here. I want to think about this now, actually, because we got this 2, 6 here. That means that this is not 2, 4, 6, because we have too many evens in here. We can have up to 2 evens on here. So it could be 1, 3, 5. That would be fine. Or it could be, actually, I think there's probably other options, right? Do we have anything forced on it? Yeah, the 4 is forced on it. I should do that. Now that this is 4, we have to do a sequence from the 4. And we have to keep going in the same direction, because if we reverse direction, we would repeat a digit, and this line cannot repeat digits. So we're going to have a difference of 1 or a difference of 2, but we know a difference of 2 would have to use all the evens. Also, it just doesn't work. We go 6, 4 or 2, 4. So we have a difference of 1, and so we're either going down to 3 and then 2, or we're going up to 5 and then 6. That makes a 2, 6 pair here. This is 1, 3, 5. All right, now these two 4s look up. That puts a 4 on here. Okay, well, we know what this adds to, and I think that's helpful. I'll explain why in a second. So why do we know what it adds to? Well, the entire box adds to 21. These add to 9. These add to 21 minus 9. 21 minus 9 is 12. So these 3 add to 12. Now, just like this line, we know that we're going to be increasing or decreasing the same amount. So as we move, because we can't repeat a digit in a box. And so think about the middle digit here. If we focus on the middle digit, like let's say it was a 4, then this is going to be some amount higher than the 4, and this is going to be some amount lower than the 4. Like this will be a 5 and a 3, or this will be a 6 and a 2, but it's always the same amount different. And so if you think about it, all we're doing is the sum of this is going to be the middle digit times 3. because the two differences cancel each other out. If we're adding one and then subtracting one, that cancels out. It's like doing 4, 4, 4 for the sum. And so, or if we're adding 2 and then subtracting 2 or some other way around, those 2's cancel out. It's like we're doing 4, 4, 4. So this actually has to be a 4. The middle digit has to be 1/3 of the sum. And so that means this is either going up to 5 and then down to 3, or this is going, or we could do it the other way, 3, 5 pair, or this is doing 2 and 6. So this would be the 6, this would be the 2, because we have the 2 here. Down here, it's the same. 21 minus 12 is 9. So this middle digit is a 3. And we're either going, oh, this digit can't be 2 or 4. So we're not doing a difference of 1. So we're doing a 1, oops. We're doing a 1, 5 pair here. And that makes this, the 4 is down here. This is a 2, 4, 6. It's not a 2. So 2's in one of these two. That places the 2 here. That's a 6. That's a 2. That means this is 2, 3, 4. These aren't 3's. That was nice. I bet we could figure this guy out. So down here we need 1, 3, 5. So our difference is definitely 2, and we're all the odds. Okay, so this is 1, 5. And so that means this is 3. This is the middle one, because we're going to do 1, 3, 5 in some way. And so this is the other even. It's 6. That makes that 4, which makes this a 2, 6 pair. 1, 5 pair, so this is the 3. So that can't be 3, meaning this can't be 5. Okay. Do we know how this 9 adds? I'm not sure. I think it's probably just the opposite of whatever these are doing. So I don't think it's worth looking at right now. This is 1, 5, 6. This is 1, 4, 5. Oh, the 4 is placed. And this is 1, 5 then. What am I missing? There must be just Sudoku, right? 3's one of these two. Maybe I do need to think about this sum. Is there really nothing else here? We have so many 1, 5's. What distinguishes these 1, 5's? 1, 2, 5, 6. This is 1, 2, 5. It's a 1, 2, 5 triple. The 3 in this column goes here. Do I really... Oh, we placed the 3. That's what does it. We place the 3 in this box, so this has to be 2. Okay, more 1, 5's. Wonderful. So we know that this is 1, 5. Wait, this is... No, I did not do this right. This is 5, sorry. Let's undo that. If this is 3, this is 5. I completely messed that up, and that resolves these. This is 1, this is 2, this is 5. That's 1 and 5. I was like, the 9 doesn't add up. That's way too much. Okay, that's 6 and 5. And so the 6 is placed here, and this is 1 and 2. There we go. That does add to 9. 1, 2, 6. This is a 6, and then these two are 1, 5 as well. All right. I just had to find the the Sudoku to do, which placed the 3 here. All right. Cool. Well, how'd you do?